Melissa, and today I'm lucky enough to be blue coating from home. I want to talk to you a bit about something called ergonomics and also give you a challenge. So in order to participate fully in this experiment, you'll need a few things. You'll need some paper, you'll need some scissors, you'll need some tape. Oh, and actually we're going to be designing chairs. It's a paper chair challenge. So you'll need something that's going to act as a load on the chair. So like a small stuffed animal, maybe a small can of food, nothing too heavy. So before we get started with this paper chair challenge, I want to think about ergonomics. What exactly is that? Well, ergonomics is design that takes into consideration efficiency and safety. I think it's really like the height of form and function. When people are buying things, they want something that looks neat, but also serves their needs and is comfortable. So the object, the structure that I really want to focus on today is chairs. So I'm sitting right now. What makes a chair? Is this a chair? Actually, it's not a chair, it's a stool. So chairs keep us seated up off the ground. I think in order for something to qualify as a chair, it's got to have sort of a back. What are our criteria for a chair if we were going to replicate one out of paper? So before we go any further, I want you to do a little bit of research. Maybe do an image search online for chairs and determine your own criteria. What makes a chair? The chair. So this is your standard run-of-the-mill kitchen chair. I mean, it comes from my house. What is interesting about it? Well, it's got like a little cushiony layer. That's kind of nice. It's been newly reupholstered. It's got this support brace here so it can withstand a larger load. That's kind of interesting. Take a look at the chairs in your house and see what you notice. So while you were gone, I decided to take a better look at this chair. I kind of got right underneath it. And it's actually quite interesting. It's got some interesting supports here, some metal bits. Like there's these wooden tabs that are actually keeping the seat in. Now, a chair isn't really a very impressive structure on its own. What are the forces acting on it when there's no one sitting on it? Well, really, it's just kind of supporting its own weight. It's keeping itself together. It becomes a lot more impressive once it becomes a load-bearing structure. So that means once somebody sits on it, it definitely gets a little more interesting. So there's going to be a lot of compression. The legs are going to feel sort of crushed down. When somebody sits and twists on a chair, that's going to act, if we didn't have this brace here, we'd probably get a little bit of a wobble in this chair. Sometimes people use chairs as a different tool. Have you ever stood on a chair? Maybe it's not a good idea depending on how your chair is built. All the forces at play really become interesting only when someone sits on them. I found another chair. Now this one's purpose is totally different than the kitchen chair. It's a camp chair. So it's made to be collapsible. It's made to be light, portable, right? So you can take it places. Another interesting feature about this chair is that it has failed. So I want to talk a little bit about a structure and what might make a structure fail. So in the case of your paper chair, you haven't built it yet, but what might be things that cause it to fail? Now, paper is a little bit of a challenging material to work with, but sometimes over time, materials sort of degrade. A lot of plastics are sensitive to UV rays, so that means the sun sort of makes them degrade over time. Sometimes just the job of bearing the load wears down materials over time. So this is a really old chair. It's not really that surprising that it has failed, and it's not that disappointing because we feel like we've got the lifetime out of it. So if you're going to construct your paper chair, how are you going to make sure that it doesn't fail. Okay, so let's get to designing this famous paper chair. Now, I really like this aspect of ergonomics. You get to sort of pick your end user and design your chair with that user in mind. Now, if you want to go really sort of clinical, you want to support something that's got some weight to it, you can use something heavier. Something, these cans, they don't really have a personality. Now, if you want to get a little more creative, you might want to design a chair for a stuffed animal. If I'm designing a chair for this bear, I might think it's like a fluffy chair. I'm not really sure. If I'm designing a chair for this Sasquatch, I might think that he's going to be really warm. So I might want to have some like air vents in order to keep him cool. So once you've chosen what your load is going to be like, you can jump into the engineering design process. So in order to design an object or a structure, in this case a paper chair, we want to look at the engineering design process. So if we look at the different icons here, they're going to represent different things. So the first one, we see the brain, we see the question, we see the idea. What is the problem? We've looked at different chairs, what makes a chair, who's going to use our chair. Now the next step is going to be to make a plan. Now this is a really important step in the engineering design process, and I highly encourage no one to skip this step. Draw out your chair. How are you going to build it? Now the next step comes when you want to test your design. So you see, you're building it, you're testing it. Now, a really fun thing about this engineering process, and I like how it's represented here, is it can be iterative. You can take a step forward and take a step back and, go through the process again. Once you've built your object, the next thing you want to do is test it out. So you're going to want to put your user into your chair. Set the load up. Is it going to crumble? Is it going to stay up? What are changes that you're going to have to do? And in the end, you want to think about that process. You want to communicate. And again, going through each one of those processes or each one of those steps in the design process at different intervals. And that's a really fun and interesting part about designing things. Okay, so here's the fun part. Now you get to go and do. Now, don't forget about the engineering design process. So we know we've identified our problem. We need to make a chair out of paper for a user that we've selected. Now, we'll want to get on paper and drawing out the plan. A really fun thing, once you're all done, your whole process is to compare your end product to your initial sort of design drawing. And oftentimes they're gonna differ. Your process is gonna change from one step to the next. So make sure you're testing your paper chair throughout. If it supports the load right away, maybe you might make it more aesthetically pleasing. Maybe it can support more load. If it doesn't support the load, if it wobbles, if it falls over, then you're gonna have to focus on the structural integrity. So there's lots of different ways to manipulate paper. I thought a little bit about maybe making my own paper chair, but I didn't want to rob you of your creativity. I wanted to let you really work out this problem yourself. Now, don't forget, this is not meant to be an easy challenge. Paper and tape are not strong materials really to build stuff with. So really think about your techniques. Maybe it's folding your paper, maybe it's making it thicker, maybe you're gonna roll it. Who knows? But keep to that engineering design process and don't give up. Try again, and that's where the most fun in this experiment will come. So I want to thank you again for coming to hang out, checking out this paper chair challenge, and hopefully you can create something fun.